Previous, welcome to part 2 of hydrocarbons. Now, we shall be talking about the class of hydrocarbons known as the saturated hydrocarbons known as alkanes. Now, remember we told you that alkanes are characterized by a single bond, in which the bond between carbon and hydrogen atoms are only single bonds in alkanes. For instance, the homologous series of alkanes begin with methane. So methane, and the molecular formula of methane is CH4, subscript 4. And if you open the structure, if you expand the structure of it, you will discover that the carbon atom is central with hydrogen atoms attached to it, hydrogen atoms attached to it, and hydrogen atoms attached to it. You will discover that the bonds between carbon and hydrogen are all what? Single what? Bonds. And so it also exists in other homologous series of the alkanes family. And the second is ethane, which has C2H6. The next is propane, which has C3H8. And the next is butane, C4H10. Now, you may be wondering, how come am I writing this molecular formula of the homologous series of alkanes without consulting anything? Now, it's simply because I understand the general molecular formula of alkanes. And that's very simple. The general molecular formula of alkanes is known as CnH2n plus 2, where n represents any positive integer beginning from 1 on and above. So you have n can take values such as 1, 2, 3, 4, and on. So when n is equal to 1, you are going to get the first member of the alkane family known as methane. When n is equal to 2, you are going to get your ethane. When n is equal to 3, you are going to get your propane. When n is equal to 4, you are going to get your butane. Now, mathematically, how do we get it? Now, for instance, in methane, you can see n is equal to 1, so you have C where it is n, we put 1. 1 H2 times 1 plus 2, and this will give us C1H2